Right, we're going to carry on with this pressure worksheet. So we know pressure is force over area. It's measured in pascals, which is PA, or in newtons per meter squared. There's another formula, P1V1 equals P2V2. There's another one that I can vaguely remember, but let's write that down. P1 over T1 equals P2 over T2. Let me check that one. Yeah, that's fine. I've come across that as well, but we'll have a look. Right, so we've done that, Right, okay, here we are. A lorry carries a load of hot asphalt, a runny mixture. So this is like liquidy. So it's runny, so that's it can move, yeah. The force on the road from one tire is 53 newtons. So there's a force on each tire being 53 kilonewtons. On each from one of the road tires. So there's one there, and there'll be some down here around the back as well. Because remember, it's not 2D, 53, and then I can put 1000 newtons, or I can put 53 kilo newtons, right? The pressure of the air in this tire is 390. So we know there's a force. Okay, so state the equation linking pressure, force, and area. So what do we say? Pressure equals force divided by area. They've written it like this: force divided by area. Okay, same thing. So calculate the area this tire is in contact with the road. So we know the pressure is 390 kilo. 1, 2, 3. That's the pressure. We know the force is, does it say, in a single tire, so that will be 53 123,000 divided by area. We don't know that, so we're going to write it like that first, then we're going to rearrange it. So this is how we're going to do it. So it equals 390 123 over 53 123, and that equals 0.14 meters squared. Right, if we had this and we knew this, all we do to stop making a mistake, we substitute pressure, which is 390 here, 390,000, and the force is 53,000. Right, okay, there you go. So area, then we can cover area up, and it's force divided by, this line means divided by area, and that's what we've got here. Okay, let's move on. Oh, replace with what? Okay, we don't want to replace. Right, a diver, not driver, a diver breathes air from a cylinder when he is underwater. Oh, I think this is quite a good question actually. The cylinder contains 8 liters. So volume is 8 liters, which is 8,000 centimeter cubed. Because remember, 1 liter equals 1,000 milliliters, which equals 1,000 centimeter cubed. The diver needs 16 liters of air per minute. In normal atmospheric pressure. So this is what's happening here. You've got 8 liters, and you've got 200 times atmospheric pressure. So the P is that and the V is that. When you release it into the atmosphere, you've got a pressure of 1 and we need to know the volume. So we know right, 1 second. It's the P1 V1 equals P2 V2 equation. So we know the pressure initially is 200 and the volume is 8. We can leave it in liters because these lot are working in liters per minute. So let's leave it in liters. So we've got 200 times 8 equals, we know the pressure is going to be 1 and we need to work out what's the volume of air. So when if this leaked and it spread out, what volume would it take up? That's what we're trying to do. So we write V2 is 200 times 8 divided by 1. We're just doing it for completion's sake, yeah. So it equals 1,600 liters. That's the first part. So now we know we've got 1,600 liters and we need 16 liters every minute. So all you do is you do 1600 divided by 16, which equals 100 minutes. So the diver has 100 minutes worth of air. Right, when the driver breathes out, bubbles are released. So that's why the bubbles expand as they rise. So what they're saying here is, look, just say that's the surface. The bubbles are small here, and the same bubble here will expand till it pops here. And why is that? Basically what happens is, as the bubble rises, the pressure decreases. Because look, this is the water. If I had a bubble here, if I measured the pressure here, it would be higher because look, I've got all this water above it. Whilst if I had a bubble here, there'd be less of a force on it. So the pressure here would be lower and the pressure here would be higher. So that's what we need to put. As the bubble rises, the pressure decreases because pressure is high times density times gravitational constant or gravity, h rho g. Yeah, so height times density of the liquid or gas times gravity or gravitational field strength. Let's just put gravity for now. Right. So we know there's a higher pressure down here. So we know P1 V1 and now we want to work out P2 V2. So since pressure is higher at the or lower down at the bottom, P1 V1 equals P2 V2. So if pressure, just say, Raquel, what we'll do is we'll do it this way. We'll say the pressure here is 10 and because it's gone up, the pressure there is 2. So we're saying 10 times, and this said the volume here we'll say is 5. So this volume is 5, and the pressure we've said is 10. Over here, we don't know the volume, but we know the pressure has decreased to 2. So we're saying 10 times 5 must equal to 2 times V2. Yeah, so we can say 10 times 5 divided by 2 equals V2. So that'll be, the volume there is 25 and the volume started at 5. Right, so the first reason, as the bubble rises, the pressure decreases, and since P1 V1, so what you would do is write this line, and we know that as the height gets smaller, the pressure will get smaller, right? Now we also know that the pressure and volume at the bottom and then when it goes to the top will be equal. So this means that the volume must increase. Also, so look, that's 1, 2, 3 points we made. Also, you can say smaller bubbles may join. It's a bit long-winded this, but you can put any of these in. Smaller bubbles may join to make a larger bubble. Right. And what else would there be? There's one more thing. Right. Okay. They've also said that the temperature at the surface is higher. If you've got higher temperature, you get a larger pressure, so it'll push the bubble out. Right, that's it. Let's leave it like that. Let's not mess about with that. It's getting a bit long in the tooth. That right. Right, a student wants to investigate how the volume of a balloon changes with pressure. Suggest how the student could measure the volume of an inflated balloon. Right. They can use a displacement method. We can use a displacement method. Use a displacement can or measuring can, or use a displacement can. So it's like, it'll be like this. A displacement can will be something like this. You fill it up, you'll get your balloon, you'll force it down, and the volume there will be displaced. And then you get a measuring cylinder and you measure how much water's come out. That will give you the volume of the balloon. We're assuming that it doesn't squash when you're pushing it down. Use a displacement can and measure the volume of the displaced water. Right, okay. The student plans to measure the pressure of the air in the balloon. To measure the pressure in the balloon, I will count how many times I push the pump. The same amount of air goes into the balloon each push. When there is twice as much air in the balloon, the pressure will be twice as high. So the pressure will be proportional to the number of times I push. Explain why the student's plan will not work. Right, this is an interesting one. So what they've said is, why is it not fair? It is not a fair test. Why? Because with each pump, it is not a fair test, because with each pump you may have a different volume entering the balloon. Also, temperature will affect the pressure. The temperature will also affect the pressure and the volume of the balloon. Right, okay. Is this the last question? Right, okay, let's get this last question and then. Right, the student wants to calculate the pressure. Yeah, I won't worry about that. So, right, okay, a student wants to calculate the pressure he exerts on the floor when he stands on 1 foot. He records these measurements. So his weight is 650 newtons. The area is centimeters squared. Complete the table by adding the weight. Unit for weight is newtons. Which piece of equipment should he use to measure his weight? A balance or a scale or no? Like, I like the word weighing scale. Suggest how the student should measure the area of the floor in contact. So what? First of all, he drew around his foot on a centimeter squared paper. Then he counted the number squares. Then he counted the number of squares covered by his foot. Okay. Right, I think that's it. That would do it. So what he could do, I suppose he could, what he could do is he could repeat it. Let's just put that in. Repeat the measurement. Remove anomalies and average out. Just throw that in. Right, okay, state the equation. So we know pressure equals force divided by area. Calculate a bit of student's foot. Right, okay. What information have they given us? They've given us a force of 650 and an area of 270. So we know pressure is 650 newtons divided by 270 square centimeters, and that gives 2.4, and they've given you the units here. Okay, so we don't put pascals or some other unit. They've given us it, so we'll leave it. Right, okay. What else have we done here? Right, okay, let's go. Oh, pressure is rho GH. Let's go up there and fill that in then. So we also know So let's put it here. That's for some reason not behaving. Pressure equals height times density times gravity, or gravitational field constant, gravity. So you'll see it as H, rho, it's a Greek letter, rho, and G. So these are the formula that are useful to know. Pressure is force over area. Pressure is mass measured in pascals or newtons per meter squared, or whatever they give you, but pascals generally, okay? And you've got pressure 1 times volume 1 equals pressure 2 times volume 2. And I've not seen this in these questions, but I've seen them in other questions where pressure over temperature 1 equals pressure 2 over temperature 2. And we know pressure for liquids, and well, it's mainly to do with liquids. Whoa, what's going on? Oh, disappearing. Right, we'll have to leave it. Right, okay, done. Thank you.